Is everyone ready? Let's get ready for chemistry! Pennies. In today's society, the penny is almost completely worthless. And also dirty and gross. And when someone hands you a penny, you can't wait to get rid of it. But did you know that your average penny is not made of copper? You take a penny and you cut it open with giant scissors of doom. What you'll see is that the inside of the penny is not copper. This is because the zinc pennies are coated in copper, so there's a little bit of copper, but mostly they're made of zinc. If the penny is old enough, though, when you cut it open, well, never mind. If I know the density of zinc and I know the density of copper, I should be able to figure out what percentage of this penny is copper and what percentage of this penny is zinc by mass. So the goal of this experiment is to determine the percent composition of the penny by measuring the penny's density. If we want the mass of a penny, that shouldn't be too hard. I can just put a penny on a balance, and that should give me the mass. If I want the volume of a penny, however, that's going to be more challenging. So we can see here that the penny, while it has a volume, the graduated cylinder, even though it is designed to measure volume, will not give us the volume of a penny. And the reason for that is most of the volume in the graduated cylinder at this point, there's a good portion of it that's just air. So we need a way to measure the volume of the penny without also measuring air. The simple way to do that is to put water in it. Now what we can do is we can add penny and we can see the volume increase when the penny is added. Now 1 penny is not giving you a whole lot of volume, so what we may need to do is use more than 1 penny. Now you can't assume that all of the pennies have the same mass. So what we'll need to do is decide on how many pennies we're going to use and put that on the balance. Not every penny has the same mass. We can't assume that they all have the same mass. So if we measure the total mass of the penny and the total volume of the penny, that should give us the density of the penny. If we take the mass of a penny and we divide it by the volume of a penny, that should give us the density of the penny. If we take the mass of 1,000,000 pennies and we divide it by the volume of 1,000,000 pennies, that's still going to give us the density of the penny. That's because mass and volume are extensive properties. If you increase the number of pennies, it will increase the mass. If you increase the number of pennies, it will increase the volume. Density, on the other hand, because it's a ratio of 2 extensive properties, is suddenly an intensive property, and that the density of 1 penny is the same as the density of 1,000,000 pennies, provided that they're all pennies. So the density does not change the more pennies you add. You can use as many pennies as you want, as long as you don't use so many pennies that the graduated cylinder overflows, or you max out the balance. All right, so now that we know the density of the penny, and now that we know the density of the zinc and the copper, the next thing to do is to calculate the percent composition. So the density of the penny is the weighted average of the density of the copper and the density of the zinc. We need to solve for percent zinc and percent copper. I have two unknowns, but I only have one equation, so I'll never be able to solve with two different variables. What I need to do is I need a second equation, and that's percent zinc plus percent copper equals 100%. So when I add the percentages up, that should give me 100%. Now I could use percent zinc and percent copper as my variables, but most students are used to seeing these as x's and y's. So what I can do is I can say, let percent zinc be x and let percent copper be y. So then my equation would be 7.13x plus 8.96y equals 7.43, and that's a little bit easier to understand for most people. Now it's just solving a systems of equations problem. There's a couple of different ways that I can go about solving this equations. The easiest, I think, is just to multiply this equation by negative 7.13. Then when I add the two equations together, the 7.13x and the 7.13x go away, because 7.13x minus 7.13x is 0. Then it's 8.96 minus 7.13, so 8.96y minus 7.13y is 1.83y, and that equals 7.43 minus 7.13. Now if I just divide both sides by 1.83, I get 0.16 with two significant figures, which is 16%. Y was percent copper, so copper's percentage is 16%. Zinc's percentage is 100% minus 16%, is 84%. Another, perhaps more familiar way to do this problem is with a substitution. So if I solve for x or y, I can substitute that into the first equation. If I subtract y from both sides, I can get x equals 1.00 minus y. Then if I plug this in for x, I can distribute the 7.13 7.13y minus 8.96y is negative 1.83y, and then 7.43 minus 7.13 is 0.3. I'm sorry, that's positive 1.83. And then 0.3 divided by 1.83 gave us 0.16, which is 16%. And we said that y was percent copper. So the percentage of copper is 16%, and then the percentage of zinc is 100 minus 16 is 84%. So once I have my two equations, I can solve them either by doing an algebraic substitution or by subtracting the two equations. Once I have one variable, I can solve for that one variable, and then I can figure out the other one from the first one. So it's just algebra at that point. Having done the lab once with Pennies, it is now time for a hard mode. We'll try it again, but this time with nickels. The nickel is a combination of copper and nickel. So we should be able to do the same thing to find the percent composition of a nickel.